Hello, grade 8 learners! This is Teacher Lay and I'll be guiding you as you continue your learning journey in Mathematics 8 for the 8th week of the first quarter. So this video presentation is all about illustrating the systems of linear equations into variables. The topic is based on the learning competency illustrates a system of linear equations into variables. So at the end of the lesson, you are expected to first define a system of equations into variables. Second, identify the three types of systems of linear equations into variables. And third, determine whether an ordered pair satisfies a given pair of linear equations into variables. Before we proceed, recall that the standard form of a linear equation into variables is written in the order ax plus by equals c, where a, b, and c are real numbers and both a and b are not equal to 0. So if we are to consider two or more linear equations simultaneously or at the same time, and are to find pair of numbers or ordered pairs that will satisfy the equations, then we are dealing with systems of linear equations. Example, we have x plus y equals 3 and x minus y equals 1, which are both in standard form. By the way, what is a system of linear equations into variables? A system of linear equations into variables consists of two or more linear equations solved simultaneously. It uses an open brace to denote the system. So say for example, we have x plus y equals 15 and 4x plus 3y equals 51. So in here, we're using the open brace to denote the system of linear equations into variables. So in here, you are interested in the solutions not of each equation, but both of them. So what is a solution to a system of linear equations? So a solution to a system of linear equations is an ordered pair that satisfies the system. And graphically, a solution is a point of intersection of the lines involved in the system. See for example, we have the pair of equations x plus y equals 3 and x minus y equals 1. So in here, there are infinitely many pair of numbers whose sum is 3. So we can say that there are infinitely many ordered pairs in the form of x and y that will satisfy the equation, and some of these are shown in the table. So similarly, if we have the equation x minus y equals 1, we can also say that there are infinitely many pair of numbers whose difference is 1. So we can also say that there are infinitely many ordered pair in the form of x and y that will satisfy x minus y equals 1, and some of these are shown in the table. So from tables 1 and 2, we see that the ordered pair 2 and 1 satisfies both x plus y equals 3 and x minus y equals 1. So if we are to consider the equations simultaneously, then we can write it as x plus y equals 3 and x minus y equals 1 with an open brace. This reads as the system of equations x plus y equals 3 and x minus y equals 1. So, the ordered pair 2 and 1 satisfies both equations, and this is what we call now the solution to the system. Generally, there are three types of systems of linear equations. First, we have the consistent independent system. Second, the consistent dependent system. And third, the inconsistent system. And all these three types of systems of linear equations can be described using their slopes, the y-intercepts, the kind of lines formed, and the number of solutions. What is the consistent independent system? So this is a system with exactly one solution. And graphically, The lines intersect at a unique point, just like the graph on the right. So we have two intersecting lines with a common point, which is called the solution. So the slopes and the y-intercepts of the two lines are different or not equal. So say for example, we have the system of equations x minus y equals 1 and x plus y equals 3. So we're going to check on the slopes and y-intercepts of the given equation. So first equation is x minus y equals 1. Rewriting this in slope-intercept form. So we have x minus 1 equals y. So y equals x minus 1 by the commutative property. So the slope here is 1 and the y-intercept is equal to negative 1. For equation number 2, we have x plus y equals 3. So, rewriting this in slope-intercept form, we have y equals negative x plus 3. So, the slope is negative 1 and the y-intercept is 3. So, comparing the slopes and the y-intercepts, so the slopes are not equal and the y-intercepts are not equal. So, using the standard form of the linear equations in two variables, we can check whether the given system is consistent or independent using this pattern. So we have A over D must not be equal to B over E, and B over E must not be equal to C over F. So A, which is the coefficient of x for the first equation, so A is equal to 1. For B, we have negative 1, and C, we have 1. For the second equation, D is 1, E is 1, and F is equal to 3. So, finding the quotient. So, we have 1 divided by 1 is 1, negative 1 divided by 1 is negative 1, and 1 divided by 3 is 1/3. So, 1 is not equal to negative 1 is a true statement. And then, negative 1 is not equal to 1/3 is also a true statement. So, therefore, we have a consistent, independent system using the standard form of the linear equations. How about the consistent, dependent system? So this is a system with infinitely many solutions. Graphically, the lines are coinciding, which means they share all the common points they have, just like the graph on the right. And the slopes and y-intercepts of the lines are equal because they are exactly the same. So say for example, we have the system of equation 3x plus 2y equals 6 and 6x plus 4y equals 12. So again, let's check on the slope and the y-intercept of the pair of equations. So let's start with the first equation, 3x plus 2y equals 6. So rewriting this in slope-intercept form, so we have 2y equals negative 3x plus 6. So dividing both sides of the equation by 2, we have y equals negative 3 halves x plus 3. So in here, the slope is negative 3 halves and the value of b or the y-intercept is 3. For the second equation, we have 6x plus 4y equals 12. So rewriting it in slope-intercept form, so we have 4y equals negative 6x plus 12. Dividing both sides of the equation by 4, so we have y equals negative 3 halves x plus 3. So the slope is negative 3 halves and the y-intercept is 3. So if we're going to compare the slopes of the two equations and the y-intercepts, then they are the same. So using the standard form of the linear equation, the ratio of the coefficients of x, the coefficients of y, and the constants must be equal. So, say for example, A is equal to 3, B is equal to 2, C is equal to 6, D is equal to 6, E is equal to 4, and F is equal to 12. So, finding the ratio of A over D, or 3 divided by 6, that is equal to 1/2. 2 divided by 4 is also 1/2, and 6 divided by 12 is also 1/2. So the ratio of the coefficients of x, y, and constants are all equal. So we have a consistent, dependent system using the standard form of the linear equation. And now, let us try some points and determine whether these ordered pairs, when substituted to both equations, will yield the true statement. So say for example, we have the system of equations 3x plus 2y equals 6 and 6x plus 4y equals 12. Using the y-intercept, which is 0 and 3, we're going to substitute to the first equation and the second equation. So 3x plus 2y equals 6 becomes 3 times 0 plus 2 times 3 is equal to 6. 3 times 0 is 0, 2 times 3 is 6, so 0 plus 6 is equal to 6, and 6 is equal to 6 is a true statement. For equation number 2, we have 6x plus 4y equals 12, so substituting the values for x and y, 6 times 0 plus 4 times 3 must be equal to 12. So 6 times 0 is 0, 4 times 3 is 12, so 0 plus 12 is equal to 12, and 12 is equal to 12, which is a true statement. So this means that 0 and 3 is a solution of the system of equations. Another example is using the x-intercept 2 and 0. So substituting the values for x and y in the first equation, so we have 3x plus 2y equals 6. So 3 times 2 plus 2 times 0 must be equal to 6. So 3 times 2 is 6, 2 times 0 is 0. So 6 plus 0 is equal to 6 and 6 is equal to 6, which is a true statement. And for equation number 2, we have 6x plus 4y equals 12. So this becomes 6 times 2 plus 4 times 0 must be equal to 12. So 6 times 2 is 12, 4 times 0 is 0. So 12 plus 0 is equal to 12, and 12 is equal to 12, which is a true statement. So this means that 2 and 0 is a solution of the system. So take note, we have two ordered pairs that satisfies the given equation, so therefore, this is a type of equation which is consistent dependent system. How about the inconsistent system? So this is a system with no solution, and graphically, the lines are parallel, which means that the lines do not have a common point, just like the graph on the right. So we have parallel lines. And the slopes of parallel lines are equal, but the y-intercepts are not equal. So say for example, we have the system of equations 2x minus y equals 4 and 2x minus y equals 2. So let's check on the slopes and the y-intercepts. So let's start with equation number 1, 2x minus y equals 4. So rewriting this in slope-intercept form, so we have 2x minus 4 equals y, or y is equal to 2x minus 4 by the commutative property. So the slope is 2 and the y-intercept is negative 4. For equation number 2, we have 2x minus y is equal to 2. So rewriting this in slope-intercept form, so we have 2x minus 2 equals y, or y equals 2x minus 2 by the commutative property. So the slope is equal to 2 and the y-intercept is equal to negative 2. So comparing the slopes of the two equations, so the slopes are equal and the y-intercepts are not equal. And using the standard form of the linear equations, we're going to get the ratio of the variables and the constants of the given equation. So A over D must be equal to B over E, and B over E must not be equal to C over F. So A is 2, B is negative 1, C is 4. For the second equation, B is 2, E is negative 1, and F is equal to 2. So we have the ratio 2 divided by 2, which is equal to 1. Negative 1 divided by negative 1, which is equal to 1. 4 divided by 2, which is equal to 2. So 1 equals 1, which is true. 1 is not equal to 2, which is also true. So we have an inconsistent system given the standard form of the linear equations. And now let's answer our activity. Choose the letter of the correct answer for each item and write your answer on your paper. Number 1, a system with exactly one solution is called A and blank. A, consistent independent system. B, consistent dependent system. C, inconsistent independent system. Or D, inconsistent system. You have 5 seconds to answer the question. Time's up. The correct answer is letter A, consistent independent system. And you are correct. Question number 2. A system whose graphs are parallel is called A and blank. A, consistent independent system. B, consistent dependent system. C, inconsistent independent system. Or D, inconsistent system. You have 5 seconds to answer the question. Time's up. The correct answer is letter D, inconsistent system. Question number 3. Which of the following ordered pairs satisfies the system x plus y equals 3 and x minus y equals 1? Letter A, 2 and 0. Letter B, 2 and 1. Letter C, 3 and 0. Or letter D, 0 and negative 1. So you have 5 seconds to answer the question. Time's up. The correct answer is letter B, 2 and 1. Question number 4. Which of the following systems of equations is consistent independent? A, the system of equations x minus 2y equals 1 and x minus 2y equals 5. B, the system of equations x plus 3y equals 5 and 3x plus 9y equals 15. Letter C, the system of equations x minus y equals 1 and x plus y equals 4. Or letter D, the system of equations x plus 2y equals 5 and x plus 2y equals negative 3. And you have 5 seconds to answer the question. Time's up. The correct answer is letter C. Question number 5. Which of the following systems of equations is consistent dependent? A, the system of equations 3x minus 2y equals 6 and 15x minus 10y equals 30. Letter B, the system of equations x plus 3y equals negative 5 and 3x plus 9y equals 15. Letter C, the system of equations x minus y equals 1 and x plus y equals 4. Or letter D, the system of equations x plus 2y equals 5 and x plus 2y equals negative 3. So you have 5 seconds to answer the question. Time's up. The correct answer is letter A, the system of equations 3x minus 2y equals 6 and 15x minus 10y equals 30. Well, that's all for today about illustrating systems of linear equations and two variables. I hope you learned something. Thank you for watching.